Hello and welcome to this next unit where today we're going to be talking about motor learning. Let's have a quick look and see what we're going to be discussing in this unit. So to start with, the first thing to notice is that all of the content in this first part of the video and indeed the second part of the video is for SL students as well as HL students. In this first section here, we're going to be looking at motor learning, and we're going to be looking at what we mean by learning, what we mean by skills and abilities and technique, and then we're going to be looking at the different learning models and models of memory. We're then going to be looking at the psychological refractory period and response time, and then finally we're going to look at the transfer of learning. In the second part of this video, we're also going to move on to look at the execution of specific skills and attentional focus. So let's get started. In this unit then, we're going to be considering the question, how are skills acquired, practiced, and perfected? So how do we move from this all the way up to this? First off, what we need to consider is, well, what do we mean by skill? When we talk about someone being skillful, what does that mean? Now, likely we can probably pick somebody out on a football pitch or a tennis court who we would describe as being skillful. When we're asked to describe what it is to be skillful, it gets a little bit more difficult. So let's think about defining skill. They define skill as the consistent production of goal-orientated movements which are learned and specific to the task. This next definition comes from Guthrie in 1952, and they said that skill can be defined as the learned ability to bring about predetermined results with a maximum certainty, often with a minimum outlay of time, energy, or both. I quite like both of these definitions because they both hit on slightly different key terminology that I think is really important for the definition of skill. In this first one, then, we've got this idea that skill is something that is consistent. It's something we can do consistently. It's goal-orientated, so there's a specific purpose to the skill that we're executing. For example, if we are just walking aimlessly around an area, that's not a skill, whereas running in a particular direction in order to cover a cross or a pass, that might be a specific goal-orientated skill. These are also learned and they're specific to the task. So it's something we have to acquire. It's not something that we're born with. And because we have to acquire it, it means we can develop them. The second definition also highlights this idea of maximum certainty. So because we're able to do it consistently, then we can also bring this idea of certainty of the outcome. And at the same time, we can minimize the outlay of time or effort. We can tell that a proficient performer is going to be able to execute that skill in an energy efficient manner, i.e. they're going to expend the least possible energy and at the same time complete the skill as quickly as possible. If we look at this example of a golfer, we can see clearly that this is something that they've had to practice. It's a goal-orientated movement. The idea of learning the skill of putting is to maximize the chance of success every time they get onto the putting green, and with the minimum outlay of time or energy. Some of the main characteristics of skills that we can talk about are that they're goal-orientated, they have a specific end result in mind, and that they meet the goal with maximum certainty. They meet the goal also with a minimum outlay of energy, and they're learned through practice. If we're talking about different types of skills, we can talk about motor skills. These are skills, for example, like weightlifting, where success is largely dependent upon large muscle movements. So these are where there's not a huge amount of precision involved, and it's largely the amount of force we can produce that's going to determine our success. We can also talk about cognitive skills, and these are skills where processing in the brain is much more important for the outcome. Indeed, an entirely cognitive skill is entirely dependent on our thinking processing and not at all dependent upon our physical movement. A good example of this might be chess. Whether you win or lose in a game of chess has nothing to do with how fast or how accurately you move the piece on the board, but it has everything to do with the thinking and the processing behind which direction and which position you're going to move the piece to. Next, we can talk about perceptual skills, and these are skills where it's really important to be able to intake information from the world around us and use that to help us make decisions. Normally, these stimuli are visual or auditory stimuli in the world of sports. A good example of this might be a golfer who is able to look at the green and analyze exactly where that shot needs to be placed in order to take into account the hill or the slope of the green to give it the best chance of success. Finally, we can talk about a combination between perceptual and motor skills. Now, in reality, a lot of sports skills are going to fall into this category. The last example that we used of the golfer on the putting green, we could argue that yes, there is a perceptual skill in being able to determine exactly where and how hard the ball needs to be hit. But unless you've got the motor capabilities in order to execute that putt, that's only half of the skill. The perceptual motor skill takes into account the ability to execute the skill by contracting your muscles and executing the movement in the correct manner. Now, in reality, as I say, these are most skills in sports that we find. For example, dribbling in a basketball game whilst being aware of the environment around us. We might be the best dribbler in the world, but if we're unable to identify threats from defenders as they position themselves on the court around us, it's not going to do us any good. We need to have the perceptual combined with the motor skills in order to execute these. Next up, we're going to talk about abilities. And quite often people talk about skills and abilities being the same thing, but there's a significant difference. When we talk about someone's abilities, we talk about general traits or capacities that they might have, and generally we're referring to things that they're born with. So they have the potential to be used in order to execute specific skills, but however, they are related to a skill, but they're not the same thing. So skills are largely defined by their purpose or their goal, whereas abilities are traits that we're born with, and these are general abilities that give us the capacity to perform a specific skill. Abilities differ from skills then because skills are learned. Abilities, however, are the product of both learning and genetic factors. Usain Bolt is an excellent example here. As the best sprinter the world has ever seen, he required a combination not just of skill but also the genetic abilities to be able to sprint at that speed. I could train for as long and hard as I like, and I'm never going to be as fast a sprinter as Usain Bolt because I just don't have the natural abilities that he was gifted with. Fleischmann in 1972 identified 20 motor abilities and then further classified them as physical or perceptual abilities. When we're looking at the 100-meter sprint, then, for example, they're largely dependent on motor abilities, for example, explosive speed or dynamic flexibility. But it also does involve some perceptual abilities, for example, reaction time. You need to be able to react as fast as possible to the gunshot going off at the start of the race. You also, to a degree, need to be able to coordinate multiple limbs moving at the same time, for example, your arms and your legs. And for most elite sprinters, this isn't going to be the limiting factor to their performance. Therefore, we can say that in terms of abilities, the 100-meter sprint is largely focused on motor abilities rather than perceptual abilities. Finally, let's consider what we mean by technique. Technique can be described as the way of performing or the way of doing or executing a specific skill. We might be able to look at somebody in the sporting sphere and say that this person has great technique, a great way of executing a specific skill. We might look at a golfer, for example, and say that they've got a great swing. That might mean that they are really particularly fluent or particularly efficient with their swing. So this is referring to a specific skill and the way in which that specific skill is performed. As another example then, we could look at a swimmer who has a particularly efficient butterfly stroke, and we might describe them as having really good technique. Let's examine then the relationship between skill, ability, and technique. The skill, or the execution of a skill as a one-off event, is a combination of our abilities and then the selection of an appropriate technique. If we look at a 100-meter sprinter then, the skill that they're executing at that particular time is a combination of their particular ability and their ability to select the correct technique for that specific environment. This wouldn't necessarily be the same should the environment change. So if we changed it from a flat 100-meter sprint to 110-meter hurdles, this would change the environment and the technique that we would need to apply would be different. Just as a reminder then, the abilities, these are innate and genetically endowed characteristics. For example, balance and coordination. These are general abilities that we can then apply to the execution of specific skills. Skills are learned and honed through experience and practice, and they translate these innate abilities into effective sports performance. Technique, then, this is what we refer to as being a specific method of executing a particular skill. This unit then is focused on motor learning. But what do we mean by learning, and, well, how do we measure learning? The way that we measure learning normally is that we have to infer learning based off a change in performance. So if we're measuring an athlete over time and we see a shift in their performance, we might infer that they've learned or they've acquired a new skill. What this means then is that it can be highly variable, because if, for example, we are tracking someone's progress through different stages of learning, it may mean that their performances go up and down and change, that they're not continually improving. This is only giving us a snapshot into the learning that's taking place, and it doesn't necessarily mean that if a particular performance is bad, that they've unlearned or they've forgotten how to execute a skill. It just means that that particular performance wasn't very good. I'm sure you've all had the experience of going into a test thinking you know the content really well, and then coming out having not done very well. That particular performance isn't necessarily reflective of your learning. Take, for example, Tony Parker. He's a 75% free throw shooter throughout his career, but yet he still stepped up to the free throw line and produced this as a free throw in an NBA game. Now, clearly we can say that his performance was appalling in this case. It didn't even make it to the basket. But the performance is something which is temporary, and it fluctuates and changes over time dependent upon loads of different factors. Can we necessarily say that from this performance that he's unlearned or has reversed and gone backwards? Not necessarily. Maybe it just means that there were other factors affecting his performance other than his level of learning. It's below par for what we'd expect for this performer. Learning, on the other hand, is a relatively permanent change in performance which results from practice and past experiences. So we need to be able to distinguish between the performance which we might use to measure or infer learning and what we actually mean by learning. The two aren't necessarily the same. When we're talking about learning, we also need to think about, well, what are the factors which are going to influence the different rates of learning between different people, and also with the same person learning different skills? What I'd like you to do is have a think about, well, what are the factors affecting how fast this baby is going to acquire the skill of walking? There are 7 primary factors which we're going to talk about when we discuss what differentiates learning rates between people and between different skills. First off then is the difficulty of the task. Clearly, if somebody is set a more difficult task to learn, it's going to take them longer to acquire or to learn that task. Next up then, we can also consider coaching techniques. We could have an amazing coach, but if that style isn't appropriate for the learner, that's going to slow down the rate at which they acquire that skill. Next up, we can talk about fitness. The fitter a learner is, the more likely they are to be able to direct more of their attention to learning the skill rather than just meeting the physical demands of performing the skill. If somebody is less fit, it means that they're going to be less able to perform to meet the requirements of that skill. It might mean that they can only do a certain number of repetitions before they're fatigued, and then the quality of the practice declines. We can also talk about the levels of maturation. Children, for example, are going to develop at different rates, and levels of maturity are also going to dictate things like levels of motivation and perseverance that a child might put into learning a particular skill. We can also think about the age of a learner. This is going to influence the cognitive and physical development of the learner, and potentially the need for a coach to adapt the task or the equipment to enable learning to take place. It also is going to dictate the amount of time, for example, that the person might need to take in breaks in order to recover and in order to absorb learning. The teaching environment is also really important. The quality of facilities has long been associated with increased rates of learning. If you've got high levels of facilities and good quality of equipment, this is going to increase the rate of learning. We can also think about the teaching environment in terms of the capacity to feel safe within that environment for the learner. If the learner feels safe in an environment, it means that they're happier to take risks, try things out, and get things wrong. This is all part of the learning process. Finally, and perhaps most importantly, we can talk about motivation. We're going to talk more about motivation later on in the unit on psychology, but suffice to say for the moment, motivation is clearly going to dictate our levels of interest and how long we remain involved in the learning of that skill. Motivation is something that drives our behaviour to do something. For example, when we're thirsty, we're motivated to find water in order to quench that thirst. Suffice to say, there can be lots of different factors that can influence our levels of motivation, and that's going to vary not just between different people, but from one time to the next. Next, in the discussion of rates of learning, we need to talk about learning curves. Now, here's an example of what we call a linear learning curve. This is where learning increases proportional to time. So the more time we spend acquiring a skill, the greater our level of skill. Now, this might be something we'd think of as being pretty common, but actually a linear learning curve like this is pretty uncommon. The early stages of learning basic fundamental skills like sorting a deck of cards might be something which is learnt in a linear fashion. However, after a short period of time, it's probably going to plateau off, so it's only going to be linear for a short period of time. What's much more common is that we might see a change in the rate of learning. Here we can see a positively accelerated learning curve. What this means is that we might experience a slow rate of learning at the start, but then once we've acquired the basic fundamentals, we see a rapid improvement in our skill level. This is something we might see with complex tasks involving multiple coordinated movements. A good example of this might be watching a baby learning to walk. That initial phase of learning just to stand up and to balance and to lift a leg up, that's going to take a long period of time. But what happens as soon as they start to find that balance point is that their rate of learning is going to increase exponentially, to the point where very quickly after taking their first steps, they're going to become quite confident walking in a multitude of different environments. Opposite to a positively accelerated curve, we might also see a negatively accelerated curve. In this example, we would see a rapid rate of learning at first, which then slows down over time. A good example of a skill which might exhibit a negatively accelerated curve are, for example, large gross movements that are quite hard to perfect. So, for example, what we'd see here in sprinting is we'd see significant improvements over those first few sessions where large errors are eradicated, but then perfecting the technique and making those small improvements once we've got a good technique are going to be much harder to come by. So the rate of learning is going to slow down. Finally, we can talk about an S-curve, and this is a combination of all of the previous examples that we've just talked about. And this, in reality, is much more likely how we're going to be acquiring skills, particularly if they're placed into a competitive context. For example, if we think about our ability to take penalties in football, it's a relatively complex skill, so we might see some slow learning at first. However, once we've got the basics and we understand them, we might see a period of rapid improvement, and then we might see a plateau that's affected by, for example, our physical maturation levels. That plateau might be broken by, for example, a growth spurt, where we rapidly increase the muscle mass of our body. And that might mean that we can then go back to a period of rapid improvement. This is how we acquire skills in reality. It's much rarer to exhibit just a single positive or negatively accelerated curve. Next up, let's talk about transfer of learning. Clearly, when we acquire one particular skill, we might acquire certain elements of that skill that are transferable to other skills. We can think about how the skills that we learned previously might impact the learning of a new skill. For example, we might see positive transfer. This is where the practice of one task facilitates the learning of another. We might also see negative transfer, and this is where the previous learning of one skill might negatively impact or reduce the speed at which we acquire a new skill. We might also have zero transfer. So in this example, we'd have two skills which are so separate that there is no impact on learning whether you have acquired a previous skill or not. An example of where we might experience negative transfer between the acquisition of skills is between learning the forehand in squash and a forehand in tennis. If we look at these two videos here, we can see that the techniques in the forehand are very similar between squash and tennis. We might assume that there's a positive transfer, i.e. if you're good at performing a forehand in squash, this might indicate that you'd be good at performing a forehand in tennis. The problem is that they are similar but fundamentally different. What this means is that actually your acquired skill in squash might inhibit your learning of your forehand in tennis. If we look at the skills again, we can see clearly in the squash video that there's a large amount of wrist flick and very little movement in the arm. Whereas when we're looking at in tennis, yes, there's a wrist flick, but there's much more movement in the forearm and the arm rotating around the shoulder. This is where there's going to be a significant difference in the skill, which might be enough in order to inhibit the acquisition of the new skill. In addition to having positive, negative, and zero transfer, we can also talk about where skills transfer from, for example, one skill to the other. This is where one skill acquired in one context is applied in another context, and that helps us with the acquisition. So, for example, being able to acquire the skill to corner on a bike and lean into the corner might help us acquire the skill of cornering in skiing, because we already have the idea that we need to be leaning into the inside of the corner. We can also talk about the transfer of skills from a practice context to a performance context. And when we're coaching sport, this is something which is absolutely key to enabling our athletes to perform. What it means is that skills we apply in a training environment can then also be applied in a competitive context. What we need to make sure then is that the training environment is as similar as possible to the competitive context in order that these skills transfer easily. The last thing we want is for the two environments to be totally separate and so zero transfer is experienced. We can also talk about the transfer of learning from an ability to a specific skill. This is where we can use those generalized abilities in order to help us perform a specific skill. So, for example, we can use our generalized ability of balance and coordination in order to be able to execute the timing of a basketball dribbling skill. Next, we can consider a bilateral transfer of learning. And this is where we are going to transfer the learning of a skill from one side of the body to the other side of the body. So as a footballer, it's useful to be able to pass the ball with both feet. So once we've acquired the skill of passing with one foot, it's good to be able to immediately transfer that learning to the other side to make sure that we can equally practice on our weak or less dominant side. Players who are bilateral have a much greater chance of being able to offload the ball, for example, in a competitive environment where they are not limited to only using one foot. We can also talk about stage-to-stage transfer of learning. This is where we might simplify a skill and make it more basic, and we then acquire the skill in that more simplified environment, and that might assist us in developing that learning in a more complex version of the same event. So, for example, we might talk about learning to play 3v3 basketball and the concepts of passing and movement in a more simplified environment where there's fewer defenders. That then can transfer to a 5v5 match when we increase the number of players. Finally, we can talk about the transfer of learning from principles to skills. And here we're talking about how acquiring the understanding behind the skills is going to help us to perform that skill. A good example of this might be a gymnast learning to perform a somersault. If they can acquire the understanding of moment of inertia and how tucking up tighter is going to reduce the moment of inertia, therefore increase the angular velocity at which they're rotating, meaning that they're more likely to rotate all around the somersault and be in the correct position in landing, this is going to help them execute that skill. For this next part of the video, we're going to talk about pedagogy. The first thing to consider then is, what do we mean by pedagogy? Well, pedagogy is the method and practice of teaching, particularly when it's applied to an academic subject or a theoretical concept. When we're thinking about pedagogy then, it's the application of teaching theory to practice. When we're considering motor learning, we're going to talk about two different types of pedagogy. We're going to talk about non-linear and linear pedagogy. First off then, let's talk about linear pedagogy. There are some key characteristics of a linear pedagogy which we're going to discuss in more detail through the rest of this unit. It's based initially on the information processing model. This is where learning takes place in distinct stages, so we're increasing difficulty as we move through the learning progression. Learning moves through different stages, the cognitive, associative, and autonomous stage. As we move through these stages, then the learning is going to increase proficiency in performing these different skills. The idea with linear pedagogy is that these skills or movements should be broken down into more simpler movements that can then be used to acquire learning. It's characterized typically by a teacher-centered approach where the knowledge or information is going in one direction, from the teacher to the athlete. The second type of pedagogy that we're going to talk about is non-linear pedagogy. In this instance, it's based on an ecological dynamics approach. What this means is an interaction between the athlete and the environment around them, and exploratory learning is significant in this type of pedagogy. The idea here is that movement skills are learned in a specific context, and this context needs to be accurate to the type of environment in which those skills are going to be practiced in real life. In order to support the learning, a teacher or a coach can modify some of these constraints, either modifying the task constraints, the environmental constraints, or the individual constraints. And generally, it is focused on a learner-centered approach, where a coach and an athlete might work together in order to find the best way forward in a particular situation. First off, let's dive into a little bit more detail about linear pedagogy. As we mentioned then, so linear pedagogy is based around this idea that we have specific identifiable stages of learning. We're moving from beginner to intermediate to advanced, or as Fitz and Posner put it, the cognitive to the associative to the autonomous stages. What I'd like you to do is watch the video that's linked to this unit, and I would like you to then fill in the table in your workbooks, identifying the characteristics of each of the different stages of learning and the implications for coaches. Let's discuss now linear pedagogy. And if we think about linear pedagogy, we remember that it's based around something called the information processing model. The idea here is that we don't simply do skills in isolation, we are constantly making decisions according to a changing environment. So we might need to choose which skill to perform, or when to perform that skill, or at what speed to perform that skill. The information processing model gives us an indication of how we might do this. In this example here then, we can see this rugby player having to make multiple decisions all the time throughout their run. They're having to consider multiple different factors and continually update their plan based on what they consider to be the best choice. At its most basic then, the information processing model is a system by which we take in information from our environment, we use it to make a decision, and then we produce a response. So we have an input, we have our central nervous system or our decision-making apparatus, and then we have the output. Now, in reality, one of the problems with this information processing model is that we don't really know what goes on in that central nervous system. We can measure the inputs and we can measure the outputs. However, we can only come up with models that might suggest how the central nervous system is working to make those decisions. It's very difficult to prove exactly what's going on inside that information processing system. One thing to remember is that these are just models which are constantly being refined. In this next task, what I'd like you to do is I'd like you to watch this animation of a tennis player returning a serve. And I'd like you in your workbooks to list the inputs, the decision-making considerations, and the outputs that they've decided upon. One of the first people, in order to try and give a little bit more detail as to what was going on in that decision-making process and the information processing system as a whole, was A.T. Welford. And in 1968, he produced this model of information processing. Now, what's important to note here from this model is that his model represents a linear process, although he pointed out in his research that actually many of these processes are carried out simultaneously. It's also worth mentioning at this point that if you look in the textbook, this shows a simplified version of Welford's information processing model. However, you need to be really careful looking at this, because there are past papers that have previously required the identification of elements of the Welford's model which are missing from this simplified version. This is why for the rest of this video and for the presentation, we're going to be using the slightly more complex information processing model that Welford published in 1968. Let's start considering then the sensation or sensory input, so this first stage of the information processing model. What we need to consider here is how do we receive information from the environment around us, and indeed from within inside our body. These are the organs which are responsible for relaying the information about the environment to the brain. We need to consider exterior receptors. These are receptors which provide information about the environment from outside the body. So, for example, our vision and auditory systems. We also need to consider interior receptors. These are receptors which provide information to the brain that come from within the body. So things like baroreceptors, chemoreceptors, and proprioceptors. All of these are providing information about the state of the body from inside. In Welford's model, he specifically separated information coming from internal sensors and from external sources. Next up, let's consider the process of perception. And in order to consider this, we need to think about our short-term memory, which is coming next. Now, our short-term memory has a limited capacity, so therefore we're going to have a problem dealing with all of the information that is being provided by our environment and also that's coming from within our own body. Welford suggested a single channel theory whereby one piece of information at a time can be considered in the short-term memory. Wickens and others argued, however, that we can deal with more than one piece of information at a time on the condition that these tasks are dissimilar. So, for example, running down the court, bouncing a basketball, and deciding whether to pass or shoot are two separate decisions being made at the same time. So we can consider the information for these decisions separately at the same time. What we need then is a system by which we can limit the intake into our short-term memory to prevent overload. This is a kind of filter to make sure that we're only attending to the relevant information. In 1956, Broadbent experimented with this filter, and he proposed a system by which all information enters a so-called sensory store. Some of that information is going to be attended to, and some of it is going to be unattended to. And then only the attended information is going to make it through this selective filter, which can then be passed on for higher level processing and be entered into our working memory. The problem with Broadbent's system of this filter is that it was largely done on experiments to do with different hearing and auditory signals. The problem with this that he came up with is that the selective filter was based purely on physical properties of that auditory signal, for example, the volume or the type of auditory signal. And it looked at people's ability to filter out this particular signal based on these physical properties. However, what it doesn't account for is for other things that might be within that initial signal that might be a determinant as to whether something is filtered out or not. For example, the meaning of the particular stimulus or the experience that someone might previously have had with that particular stimulus. So, for example, someone might be listening to a conversation and at the same time they might hear their name being used by somebody else on the other side of the room, and their attention might automatically switch to the use of their name because of the familiarity of that stimulus. Broadbent's filter doesn't recognize this, and so it doesn't explain how this is possible. In 1964, a researcher called Sweats produced their signal detection theory. They proposed that we receive more than 100,000 pieces of information per second, and perceiving an important piece of information is therefore going to be problematic. The idea is that this non-essential information, what they refer to as noise, covers all information that is not part of the signal or the appropriate information that we need to be attending to. The probability of detecting a signal depends on a number of different factors, including the intensity of the signal compared with the intensity of the background noise. Now, when Sweats referred to background noise, they could mean literally noise, but it could also mean other distractions which are likely to detract our attention away from the signal. The interaction between these two variables, known as d' and the criterion, follow as such. So d' is the individual's sensitivity to the signal. The efficiency of the person's sensory organs, so for example their eyes or their vestibular apparatus or their hearing, that's going to obviously have a large impact on your ability to perceive the stimulus. If, for example, you're colourblind, you're much less likely to be able to pick out a tennis ball on specific coloured backgrounds than somebody who isn't colourblind. The experience of the individual is also going to have a significant impact on the person's sensitivity to that signal. For example, if you are familiar with picking out a tennis ball on a coloured background, this is a signal that you're used to, and so therefore you're much more sensitive to that signal. In terms of the criterion, then, this is the effect that a person's bias might have on the detection. In this case, we can talk about arousal level. Too low a level of arousal and we might miss this signal. This is known as an error of omission. Too high a level of arousal and we might actually perceive a signal where none is there. This is called an error of commission. An example of this might be if we are waiting for a gun to go off at the start of a running race and we false start because we erroneously perceive to hear the gunshot going off where we expect it to. Let's look now at some sporting examples. A good example here might be an American football player who misses a catch. They might mistime this because whilst they're trying to attend to the important information of the trajectory and speed of the ball that's approaching them, they're distracted by the background noise. This might include, for example, the noise of the crowd shouting at them, or it might include other stimulus such as an opposite player rushing towards them. We can also talk about the false start in a 100-meter race. This is a good example of where somebody might be expecting to hear a stimulus, and high levels of arousal might convince themselves that they've heard the initial signal. This, as we said, is an error of commission. We can also talk about how somebody, for example, performing a free throw in basketball might be distracted by the fans behind them. We can talk about the signal detection process in a number of different contexts. We can see a number of different examples here with the advertising and the high visibility clothing and the traffic lights, where designers have gone to specific lengths to make the signal stand out from the background noise. In terms of the advertising, having the brightest and the boldest and the most standout colours is going to increase the level of attention given to that particular advertising. With the visibility clothing, the brightest colours are going to be used in order to attract the viewer's attention. In terms of the traffic light, we can see that the background of the lights has been made deliberately black to increase the contrast between the colours of the lights. We can also see some examples of where the signal detection process has been harnessed in order to reduce the likelihood of detecting the signal. Designing camouflage gear for soldiers such they can blend into the background is really important in increasing their ability to move around unseen. We can also see in nature how this owl has adopted patterned shapes on their feathers that makes it look like or blend into their background in the bark of this tree. If we go back to Welford's information processing model, what we can see is that there's a number of different elements here that feed into perception that are missing from that simplified version we see in the textbook. Crucially, the ability for feedback and the long-term store to influence perception. As we saw from Swetz's argument then, the idea that experience can play into determining which signal is attended to is really important. This model also highlights the short-term store and decision-making as separate but crucially linear, which again is not the same with the model in the textbook. Let's move on now to consider the elements of memory. And Tulving in 1985 described memory as being the capacity that permits organisms to benefit from their past experiences. So how do we use our previous experiences that are stored in our brain somewhere to influence what's going on at the time? This is crucial for learning because we need to take on board our past experiences in order to improve our performance at the time. Welford split the short-term memory into short-term store and decision-making. He talked about the short-term store being the stage at which information, once deemed relevant in the perception stage, is stored for a short period of time before it can be passed on to the decision-making stage in accordance with the single-channel theory. The idea being that the short-term store had a limited capacity and a limited duration. 90% of the information is going to be lost within the first 10 seconds, and it has a limited capacity of 7 plus or minus 2 pieces of information, according to Miller in 1956. The decision-making element of the process, this is where the information which has been deemed relevant and passed through the short-term store is used to make a decision based on the information being received. Once that decision has been made, that information is then passed on to the effector mechanism, and also a copy is sent to the long-term store. This is what enables us to learn from our past experiences. This long-term store then acts as a reference library for past experiences. The key point in Welford's model is that the information from the long-term store can be used in the perception mechanism. This goes along with what Sweats was saying in terms of his signal detection theory, and it's where information can be retrieved from our long-term memory and used in the perception stage to determine which information might be relevant in the specific environment that the person finds themselves in. This can then follow around the cycle into the short-term store and be used to act upon and make a decision. In addition to Welford's model, we can also look at alternative models of memory. The multi-store model of memory proposed by Atkinson and Schifrin in 1968 includes a short-term sensory store, a short-term memory, and a long-term memory. So these are similar to Welford's but in a different arrangement. They're much more in a linear arrangement pathway. In the multi-store model, we can see here the linear arrangement of the different memory stores. We can see information being taken from the environment around us or from within our body into the short-term sensory store. That then has to pass through a selective attention filter in order to be taken up into the short-term memory. In order for information to be taken from the short-term memory and stored in the long-term memory, we need rehearsal. We then have the long-term memory from which we can retrieve information back into the short-term memory in order to make decisions. What we can see then in terms of comparisons with Welford's model is we can see the short-term sensory store. And this is what is equivalent to what Welford refers to as a very brief peripheral store, a pre-perceptual store that Welford mentions but doesn't include in his model itself, so he includes it in his research. The selective attention filter, this is equivalent to the perception phase in Welford's model. This is where irrelevant information is filtered out and is not passed through to what Welford calls the short-term store. The short-term store, if you remember in Welford's model, refers to the first part of the short-term memory, which is split between the short-term store and decision-making. So the models are quite similar, they just use slightly different names to refer to some of the different stages of the process. If we look at the characteristics of these different elements of the process, we can see that the short-term sensory store has a very short duration of about half a second. It has an almost unlimited capacity and contains almost all of the information that we perceive from the world around us and from within our body. Selected information can then be passed on to the short-term memory for further processing. The short-term memory, which in Welford's model consists of the short-term store and decision-making stages of the process, this is when 90% of that information is lost within the first 10 seconds. It has a limited capacity, which according to Miller is 7 plus or minus 2 bits of information, and it also has a limited duration. This short-term memory receives coded stimuli from both the STS or the short-term sensory store via selective attention and the long-term memory via the retrieval process. The short-term memory then sends information to the long-term memory for future reference via rehearsal. The long-term memory in this instance, this is where our long-term information of past experiences are stored. In order for information to be moved from the short-term memory, or in Welford's model, the decision-making process, we need to physically rehearse, or we need to decide upon that particular action. The long-term memory has no capacity limitations, although the problem is sometimes we actually have a problem in retrieving information from the long-term memory, particularly if we haven't attended to it in a long time. So the multi-stage model proposed by Atkinson and Schifrin has similarities with Welford, however it has an emphasis on this method of transfer between one stage of memory to the next. So does this mean that we can't change the characteristics of our memory? Well, no, like most things, our ability to remember can be improved through practice. Or we can develop a strategy. As an example, then, what I'd like you to do is try and remember this string of 12 letters. Okay, now you've committed them to memory, what I'd like you to do is repeat the string of 12 letters in order. Some of you might be struggling to do this because it's more than that magic number of 7 plus or minus 2 pieces of information that Miller suggests is the limit of our short-term memory. Now what I'd like you to do is try again with this string of 12 letters. Now I'd like you to repeat the letters that you've just seen. Still finding it difficult? Have a look again, and would it help if I pointed out that we can chunk this up into 4 sets of 3 letters? Some of you might have recognised that MTV, CNN, ABC and Fox, the letters for 4 of the biggest broadcasters in America. In this case, what this means is we only have to remember 4 pieces of information rather than 12. In reality, these are the same 12 letters that I used at the beginning of this test. But in this orientation, we can chunk them together and remember them much more easily. A sporting example of this might be that when we're learning to breaststroke, the 3 actions of reach, glide and pull are better remembered as one continuous movement rather than breaking it down and remembering each individual movement. This is what we know as chunking. So this is where different pieces of information can be grouped together to be remembered as a single piece of information. The idea of chunking movements together is where we start thinking about motor programs. In 1968, Keel defined motor programs as being a set of muscle commands that allow movements to be performed without any peripheral feedback. His idea was that these get stored in the long-term memory in different levels depending upon their complexity. Here we can see a diagram demonstrating the different levels of these motor programs. Keel suggested that we have at the top an executive motor program which represents the entire movement that we're trying to reproduce. Below that we might have motor programs, and motor programs might be divided into subroutines. So as an example, if we have a baby learning to walk, the executive motor program might be walking. A motor program might be the ability to balance. And within that motor program, the ability to transfer weight from one side of their body to the other could be a subroutine. As the baby becomes more proficient at walking, less attention has to be devoted to that executive motor program of walking, and that can be relegated to a motor program, and a more complex executive motor program can be included above. Keel's 1968 work on motor programs were an example of movements that relied on open loop control, i.e. they did not rely on recourse to feedback. So open loop control is designed to not have recourse to feedback throughout the movement. It either takes place very quickly or the skill is well learnt, and so therefore feedback is either not possible or not necessary. There's no time for the feedback to alter the movement as it continues. The idea is that there's a stimulus, a memory trace then initiates the motor program, and then they have the motor action or the output. An example of this might be swinging a baseball bat. Once the player has committed to the swing, there's no possibility to check that swing once it's gone beyond a critical moment. The idea is that once that motor program has been initiated, it cannot be recalled or changed because there isn't enough time for feedback to take place. In reality, this is quite a simplistic idea, the idea that feedback isn't possible to change a motor program. We can also look at a closed loop theory of control. In this case, we can see that movement is able to be altered during its execution via a feedback mechanism. So for example, in this gymnastics balance here, the gymnasts are able to adjust their positions based on the feedback. We have a comparison here between past experience and the current performance, and knowing what success feels like is going to enable them to maintain their balance and their position in order to ensure success this time. In this case, we have a stimulus or the input. The memory trace then initiates the motor program, and we have our output in the same way that Keel suggested. However, in this case, there's also a feedback loop which acts as an initial ongoing stimulus such that the memory trace can be adapted throughout the movement. Adams's closed-loop theory, proposed in 1971, went a little bit further than this and suggested two elements: a memory trace, which is responsible for selecting and initiating the movement itself, and then a perceptual trace, which, once the movement begins, the information from the muscles gets fed back into a feedback loop, which allows the perceptual trace to be used as a comparison point against the current performance. The key theory here is that the role of feedback is important in not only initiating the movement but also controlling the movement throughout its execution. So we have a stimulus or input, the memory trace then initiates that movement, and then the perceptual trace then acts as a reference of correctness throughout the execution of the movement. The motor action or the output, that is then produced. And feedback then allows error detection, which feeds back into the perceptual trace and compares the current action with this reference of correctness. The feedback also loops back into the memory trace through repetition. Repetition strengthens this memory trace, increasing its detail and meaning that we're more likely to be able to initiate that movement more accurately and quickly in future examples. Finally, we can look at Schmidt's schema theory proposed in 1975, and it has some similarities with the motor program theory that was proposed earlier. Schmidt developed an explanation of motor programs which included both open and closed-loop control. He described schema as being a set of generalized commands or rules for a group of movements, a set of movements, as opposed to Adams's specific traces for each specific movement. The problem with Adams's closed-loop theory implied that for each specific movement there had to exist a memory and a perceptual trace that could be utilized as a specific comparison of correctness. This would mean that there would have to be huge amounts of memory used up in storing these traces for every single movement we'd ever completed. The idea of Schmidt's schema theory is that only more generalized schema were used that could then be applied to specific situations. Schmidt proposed two kinds of memory, which he called recall and recognition schemas. The recall schema is the memory with regard to the choice and initiation of the action, similar to Adams's proposed memory trace. The recognition schema is similar to Adams's perceptual trace, and this is used as a memory for the feel of the movement, and it allows us to make appropriate changes in the action. So it's similar to Adams's theory, but subtly different in that the schema that Schmidt proposed are much more generalized and can be applied to a group of movements rather than one specific movement. This overcomes the memory limitations for Adams's proposition. The idea is that both schema require the individual to recall memory from similar past experiences from the long-term memory. These are then stored in the short-term memory and allow the person to decide on the actual movement to be used in that specific example. These response specifications, or the specific responses required for that exact movement, are then decided upon within the short-term memory, using both the generalized schema and information regarding the present situation that's being inputted into the short-term memory. This diagram here shows a slightly more simplified idea of Schmidt's schema theory. So in the long-term memory, we have the recall schema for passing a ball. We also have the recognition schema for passing, and that's the memory of the feel of the movement. We also have input from the initial conditions, so these are the sensory inputs relevant to that specific situation we're experiencing at the time. This information is then used in the short-term memory in order to select an appropriate response specific to the situation which the person finds themselves in at the time. So they might use their information of the generalized passing schema they've downloaded from the long-term memory, combined with the initial conditions to decide they're going to execute a chest pass in a basketball game, from all of the different passing varieties that they could have chosen. This is then relayed back into the long-term memory to then strengthen the schema stored in the long-term memory. The initial conditions, the response specifications, the sensory consequences and the outcome or the knowledge of results are going to influence the schema and update them continuously. When we're talking about Schmidt's schema theory, please bear in mind the theory states that we have these generalized motor schema, which can then be retrieved from the long-term memory, combined with the initial conditions to decide what is the most appropriate response for that specific environment. The idea being is that the less memory is required in order to store this information because the schema are generalized, not specific. In the textbook mentions generalized motor patterns and subordinate motor patterns. The idea implied in the textbook is that we have a generalized motor pattern, for example, for an overarm throw, and then subordinate motor patterns. For example, we would have a subordinate motor pattern for a cricket bowl or an American football throw or a basketball throw or a javelin throw. These being more specific motor patterns which can be attributed to the generalized motor pattern. The problem is that this is not what Schmidt was saying with his schema theory. Specifically, he argued against having specific motor patterns for each different movement. Unfortunately, because the textbook doesn't provide any references for this section, it's very difficult to determine exactly what they're referring to here. Quite often this is mixed up with Keel's suggestion of different levels of motor program, of executive motor programs and subroutines, and the idea of relegating complex motor programs once they are acquired to lower levels of motor programs. However, this is significantly different to what Schmidt was suggesting in his schema theory. Please bear this in mind. Next, we're going to talk about the effector mechanism. This is split into two parts in Welford's model, the effector control mechanism and the effectors themselves. The effector control mechanism is the process by which the decisions are put into practice by sending impulses to the muscles, causing them to contract, coordinating these impulses in order to make sure that the muscles contract at the right time. We then can talk about the effectors. These are the muscles themselves which will cause the contractions and the movements which are desired. Finally, we can talk about the feedback mechanisms in Welford's model. What we can see here is that there are three methods of feedback which he's identified in this model. In reality, he talks about more methods of feedback. However, we're going to limit ourselves to these three that he's identified. The shortest of these feedback loops is from the effectors back into the effector control mechanism. So this is an intrinsic feedback loop. So it's kinesthetic awareness of what your muscles are doing. And this might allow us to make small changes to our effectors throughout the movement if time permits as the movement continues. It doesn't, however, allow us to revisit the decisions that we've made in executing the movement itself. We can then see a slightly longer feedback loop, which is also intrinsic, going from the effectors back into the perceptual mechanism. Since this feedback is longer than the initial feedback loop from the effectors into the effector control mechanism, it takes a little bit more time to be processed. However, it allows us to perceive information from our muscles in order that during long movements, information can be used to correct latter parts of that movement. We can update the plan and the decision making during the movement if it's long enough in order to do this. An example would be the ability to change our balance point as we balance on a balance board. During the movement, we can change and update our plans and our movements as we go through the process. Finally, we also have an extrinsic feedback loop, and this is where information goes all the way back through our sensory organs and how we receive external feedback. This might be external feedback from a coach or information from a stopwatch, and this will give us information generally after the movement has been completed. So we can use it for the next time we execute a movement. However, it's not going to make a difference generally in the movement that we're completing at the time. For example, if we're learning to tackle in rugby, after each tackle, extrinsic feedback is used to correct errors. For example, from the coach, and this might help us to identify errors in our technique and provide future reference for improvement. Now we've talked about the different feedback loops from within Welford's model. Let's talk about the different types of feedback it's possible to receive. We've already talked about intrinsic and extrinsic feedback. So intrinsic feedback comes from within the athlete and is, for example, the feel of a movement. As an example then, if we hit a tennis ball with a tennis racket, we can feel whether we've hit the ball with the sweet spot of the racket based on the vibrations that we can sense coming down the racket and then our arm. Extrinsic feedback comes from outside the athlete and is provided by something else like a coach or a stopwatch. This can be provided concurrently, i.e. during the performance, or after the performance, which is known as terminal feedback. Next, we can talk about knowledge of performance and knowledge of results. Knowledge of performance, this is where we get information regarding the quality of the movement, the nature of the movement, how well executed the skill was. We get an idea of the feel of the movement and knowledge of the sensory consequences. So did it feel good when we executed the skill? We can receive this concurrently or terminally at the end of the movement. We can also receive this information from internal or external sources. Knowledge of results then is when we're receiving information about the outcome of our performance or our action. This is mostly visual or time-based or distance-based and tends to be objective measurements. So, did we win or lose? How much by? How fast did we run our 100-meter sprint? Things like that. One of the problems with being obsessed with knowledge of results feedback is that we only care about whether we won or lost. We're not really interested in examining why we lost or whether our performance was good, resulting in a good result. In this case, we can see athletes becoming obsessed with just winning and not attributing enough importance to the performance themselves. Next, we're going to talk about negative and positive feedback. Negative feedback, as the name suggests, concentrates on errors or negative elements of your performance. It should always be followed by prescriptive feedback as well, so identifying what you should do to improve. The timing of negative feedback can be really important as well. Immediately after a performance perhaps isn't the best time to tear into a player about the negative elements of their performance, particularly if you've just lost. It can be incredibly demotivating as well, especially to beginners. Positive feedback, on the other hand, as the name suggests, focuses on what you did well and the positive elements of your performance. It can just be visual, for example, a coach giving a thumbs up from the sideline, meaning that you did well. If you're an experienced enough athlete, probably you'll understand exactly what this means and which elements you did well at, but it could always be followed up with more prescriptive feedback. Feedback is an incredibly useful tool within the learning process. It can be used to motivate an athlete, it can be used to reinforce learning points, it can also be used to cause adaptations of performance, but it can also be seen as a punishment if we use negative feedback. So it needs to be very carefully applied. Different athletes are going to respond in different types of feedback in very different ways. Next, we're going to look at nonlinear pedagogy. The first thing we're going to look at is the ecological dynamics theory. This is the theory that describes how individuals continually reorganize the human movement system in response to perceived events. The idea here being that the movement that we see is a result of an interaction between the person and their environment. Movements themselves are then influenced by the objects around us, the rules of the game, the people and the players that we interact with. The idea being the cricketer in the image below can reorganize their movement system in order to capitalize on the specific environmental constraints which are presented to them in this particular task. This can then be applied to multiple different situations and different environments with ease. The dynamical systems theory is a major contributing part to the ecological dynamics theory. It explains how these complex systems, such as ourselves, will self-organize different components, otherwise known as degrees of freedom, in order to learn different skills and create movement. An example would be how a motor response to a visual prompt involves the coordination of the eyes, the visual cortex of the brain, other decision-making parts of the nervous system, and also the muscular system as well. How all of these different components act together in order to initiate that desired movement. This self-organization takes place under different timescales. Timescales for the performance, i.e. could be in milliseconds or seconds or minutes. Learning, which might take place over hours or days or weeks, or expertise acquisition, which might take place over months or years. Dynamical systems theory proposes that the self-organization process in athletes is shaped by different constraints. Newell in 1986 proposed these constraints that might lead to different learning outcomes. They identified three different types of constraints: task constraints, which might include, for example, rules of the game, the size of the implements being used, the surface that the game's being played on. He also identified different individual constraints, and this he split into structural and functional constraints. Structural constraints are to do with the physiology of the individual, so for example, the chronotype, the height, the weight, the muscle to fat ratio of the athlete. And the functional are the behavioral elements of the athlete, so their cognitive ability, their motivations, their emotions. Finally, he talked about environmental constraints, so physical factors such as the altitude, the noise, the surface, the temperature of the environment, and also social factors which might influence the environment, such as peer pressure, social norms, or cultural expectations. The ecological model refers to this continuous reorganization of different components to satisfy the constraints of the competition or the environment. This is otherwise known as adaptation. In this way, an athlete is constantly reorganizing these system components in order to achieve a specified outcome. For example, then, a quarterback is going to have to be able to adapt to the environment that they're presented with. Throwing a perfect pass is going to require different adaptations to the environment that they're presented with, i.e., they might be fatigued when they're nervous as it's the last play of the game, they're in front of noisy spectators, in a windy stadium, and whilst defenders are all constantly adjusting their positions. The ability to adapt and reorganize these components quickly is going to determine the success of the outcome. This ability to adapt is sometimes known as the adaptive capacity of an athlete. This can be developed in training by increasing the number of different constraints and modifying them by the coach during training scenarios. Perception-action coupling refers to the relationship between an athlete's actions and the information from the environment. The idea is that the athlete can directly perceive this information from the environment without necessarily having to interpret or process that information. The idea is that the environment provides opportunities for action, which we know as affordances, and athletes can use these affordances or opportunities in order to exploit them and achieve their goals. What can also happen is that other players can then respond to this particular player's actions, and they can close down or reduce these affordances and change the opportunities as the competition proceeds. In this example here, we can see Tadej Pogačar choosing to attack his compatriot Jonas Vingegaard halfway up a climb. He's detected the fact that the pace in the climb has just slowed slightly, and he sees that as an opportunity to try and attack. When he looks behind him, he can see that he's made a gap between him and Jonas Vingegaard, so this is a good opportunity to push on further and try and widen that gap. Often in the acquisition of skill in individual and team sports, an athlete's performance will depend largely on their ability to identify these key moments from the environmental information. So training should take place in a number of different environments in order that the athlete can try and perceive this information in the training environment that can then be translated to competition. From an ecological dynamics perspective, it's not just techniques which transfer across from the learning environment to a performance environment. It's things like perception-action links, i.e. being able to read the environment and respond correctly, decision-making under pressure, and also awareness of affordances from environmental cues. These are all important things which need to transfer across from the learning environment to a performance environment. This is a good reason why the training environment must reflect the performance environment, and it must reflect that environment in a number of different ways, in terms of opponents, the amount of space you've got, the level of competitiveness, the pressure, and the unpredictability of the environment. For example, setting up a passing drill where there's no opponents, that's going to result in low levels of transfer, whereas setting up a high-pressure competitive passing drill, that's going to result in higher levels of transfer between the training and competitive environment. This might not happen automatically. It might even take quite a long time for those skills to be transferred across from a learning to a performance environment. For example, if skills have been acquired in a learning environment, it may take some time in order to adapt these skills into a more competitive environment. So well-learned skills don't always transfer across immediately. It may be that a transition period is required. So you might be asking, well, why don't we just compete continually, and that's going to help us to learn in that environment? However, the problem here is that a learning environment is not the same as a competitive environment. The competitive environment, where there's constant high levels of pressure, discourages adaptability, and it discourages being able to try different things that might be used in different scenarios but might have a negative outcome. A learning environment requires an environment which mimics the competition, but also it's more forgiving to mistakes and to allow adaptations. A learning environment needs to be subtly different to the competitive environment, such that mistakes aren't punished and the exploration is allowed for the athlete to be able to explore different ways of doing things. The ecological dynamics approach suggests that early specialization into a specific sport is not the way to future elite performance. Actually, athletes early on in their career should be experiencing a variety of different physical activities. This is the way that they can increase their amount of experience in different environments and increase their adaptability to different changing environments. An exception to this rule could be Tiger Woods. So he pretty famously was given a golf club almost as soon as he could walk, and we all know he went on to become one of the greatest golfers of all time. However, it's important to recognize that he is an exception and not the rule. Physical educators and coaches should take into account a constraints-led pedagogy. This is because human learning is non-linear, and this needs to be reflected in the way that coaches and teachers actually impart knowledge to their athletes. This means that they need to incorporate a non-linear pedagogy into their teaching. For example, they need to focus on being able to assess performance and learning continually. They need to be able to structure practices to facilitate the optimal learning environment for that athlete. Then they need to be able to deliver concise instructions and feedback, and that allows the learning to take place in the most efficient manner that can then be adapted to a different and changing environment. So to recap then, we can use this diagram which you'll find in the textbook. So the pedagogical approach is based on an ecological dynamics theory. We've talked about the different constraints which influence the behavior and the learning outcomes of the athlete, the personal, task, and environmental constraints. We've talked about the ecological dynamics theory, which explains how an individual reorganizes their movement systems in response to perceived events and environmental constraints. We've talked about degrees of freedom and how the different components within this system interact and work together. We've also talked about perception-action coupling, so the relationship between the participant and the actions of that participant and the information provided by the environment. This might be things like affordances or opportunities which can be used by the athlete to capitalize on or take advantage of. We've also looked at how coaches and athletes might need to take into account the non-linear nature of human learning and the fact that activities might need to be put into performance settings in order to help learn and acquire some of the skills other than simply the techniques that need to be developed. This performance variability is really important in order to be able to perform in changing environments where those constraints are going to be changing all the time. Coaches can manipulate these constraints in different learning environments in order to try and simulate this. Adaptation then takes place according to different constraints, and the athlete or performer is expected to respond to the changing constraints. This all helps in the discovery and exploration of different affordances provided by the environment, which hopefully will be recognized in a competitive environment. To end the first part of this video, we're going to talk about the psychological refractory period. Before we do this, we need to understand a couple of bits of terminology, so what we mean by reaction time and response time. Here's a video showing an example of a motorcyclist driving around the Isle of Man TT course. We can immediately see how reaction time is going to be something that's incredibly important to be able to respond to the different stimuli which are coming very quickly at them. So first up then, we need to consider what's the definition of a response time. Well, response time is the time from the introduction of a stimulus to the completion of the response. It's made up of two distinct parts, the reaction time and the movement time. The reaction time is the time spent thinking about and processing the information and initiating the movement. The movement time is the time taken to execute the actual physical response. Altogether, then, this is the response time. So we can see here that people often use reaction time and response time incorrectly. Most reaction time tests are actually testing response time because they're expecting you to move a part of your body in order to initiate or stop the top, because they're expecting you to move a part of your body in order to stop the clock. If we think about factors that are going to influence response time, we can split this again, thinking about factors that are going to influence reaction time and factors that are going to influence moving time. Factors that are going to influence reaction time are things like our arousal level, the ability to recognize the stimulus, the decision-making time, i.e. the complexity of the response, so how many different options are provided, the nerve transmission time, the amount of practice we've had, and any element of anticipation that we might be able to use. Movement time then, generally that's going to be determined by our levels of fitness, how strong we are, how fast we are, our gender and our age. These are the things which are going to affect our moving time. One of the factors that's going to influence reaction time is Hicks' law. Hicks' law states that the time required to make a decision is a function of the number of options available. It's used to estimate how long it'll take for people to make a decision when presented with multiple choices. What I'd like you to do though is I'd like you to sketch a graph demonstrating the relationship between the number of alternative choices and the time taken to respond. Sketch that in your workbooks below and try and think about a reason to justify the graph you've chosen. Hopefully you drew a graph that looks something like this. The explanation being that as we increase the number of choices, what we see is initially a significant increase in the reaction time required to make the choice between the different responses. However, as we start increasing the number significantly, we reduce the additional time taken to make the choice. If we think about this, the time difference taken if I was offered 50 choices and 51 choices is not going to be significant. However, the difference between one choice and two choices is going to be a significant difference. Now let's talk about the psychological refractory period. The idea here being that if a stimulus is presented, then we get a normal reaction time, as we would expect. The stimulus is processed, a decision is taken, and the response is initiated. However, if halfway through responding to that first stimulus, a second stimulus is presented, then we're going to see a slower than normal reaction time in response to that second stimulus. The idea being that we have to process the response to stimulus 1 before we can start processing the response to stimulus 2. This delayed reaction time in response to stimulus 2 is known as the psychological refractory period. We can see in this diagram here a graphical representation of the psychological refractory period. What we can see here is the presentation of the first task or the first stimulus. Obviously, it's going to take a little bit of time to perceive that stimulus, and then we go into the response selection phase. This is the decision-making process. If during this time the second stimulus is presented, so slight delay behind the first stimulus, we then can start perceiving the presence of a second stimulus. However, we can't move on to the response selection phase until we've finished selecting the response to the first stimulus. This is what we call the slack phase or the psychological refractory period. Just so you know, the SOA is the stimulus onset synchrony. That's the time difference between the first stimulus and the second stimulus. This is quite important because if this is too short, it means that the person has only just started to perceive the first stimulus and then can switch very quickly onto the second stimulus without much of a refractory period. If this difference is too much, it means that the first stimulus has already had a response selection decided upon, and so therefore the switch to the second stimulus again isn't very much delayed and the refractory period is quite small. This is why the timing of when you throw a dummy to an opposition in a game of football or basketball is particularly important. The idea here being that there's a single channel mechanism, so only one stimulus can be processed at a time, and only after that stimulus has been processed can we then respond to the second stimulus. We can see here in this video a number of different examples in sports of where people have given one stimulus and then the player decides to give a second stimulus. The response to the second stimulus is delayed because the processing has to take place of the first stimulus. This is a really good example. Stimulus 1, stimulus 2, response being delayed. So the feint is stimulus 1 and the actual movement is stimulus 2. The idea being the defender is going to be slow in reacting to the real movement.
Hello and welcome to this next unit where today we're going to be discussing the second part of C2, which is attentional control. Let's have a quick look at the syllabus and see what we're going to be covering. First up then, we're going to be discussing how attention can be focused either internally or externally, and that focus can either be broad or narrow. We're then going to talk about how we lose concentration, and that can be as a result of either internal or external distractors. We're then going to discuss controlled distraction as a technique for improving performance. And then we're going to look at attentional narrowing in high arousal situations. And finally, self-talk as a method of improving performance. First up, attention is the concentration of mental activity on a task at hand. And it's a crucial prerequisite for any kind of success in any field, particularly in the sports. Moran 2012 proposed 3 cognitive dimensions of attention. The first one being concentration. Concentration is a deliberate decision to invest time and mental effort on what is most important in any given situation. So, for example, focusing and concentrating on making good contact with a ball when we're shooting in soccer. The key part of this definition here is that it's a deliberate decision. It's not something that happens without thinking about it and making conscious decision. Next up, let's discuss selective attention. So this is where athletes have an ability to zoom in on the relevant cues for a particular task, whilst ignoring potential distractions. It's this ability to zoom in and focus without being distracted that's particularly important for selective attention. Finally then, we've got divided attention. So this is almost the opposite. This is the ability to zoom out and to be able to coordinate 2 different actions at the same time. So for example, being able to look one way while passing accurately in the opposite direction to a teammate. The idea here being that selective attention identifies the right information and concentration maintains focus upon it. Concentration is really important, particularly in sporting endeavours. Let's have a quick look at some of the different terminology that we use, because quite often we'll use concentration, attention and focus interchangeably, and it's not always the case that they mean exactly the same thing. Let's see if we can unpick the differences between them. To start with then, concentration is the ability to perform with a clear and present focus, whilst focus is the central point of your attention, whatever it is that's most important that is attracting your attention. Attention, on the other hand, is the active awareness of what you're observing. So it's not just a passive observation, we're actively being aware of what we're observing. It's a conscious effort. As we can see then, there's slight differences in the terminology that distinguishes between each of them, and it's really important to understand these. Concentration is the ability to control attention and concentrate on the demands of the task at hand. And as you can imagine, it's vital for high-skilled performance in sport. In sport then, concentration has a number of different aspects, including the ability to focus on relevant cues within the environment, so therefore selective attention. The ability also to maintain that attention over a long period of time. We can also think about concentration as having an awareness of the whole situation. So not just being able to focus on one tiny detail, but also having an awareness of the whole situation going on. We can also think of it as the ability to shift that attentional focus between the small details and the large overview in terms of this whole situation. We're going to use Alex Honnold as an example in sports. If you remember, he's the rock climber who specializes in a particular type of climbing called free soloing, where he climbs these enormous cliffs with no safety equipment whatsoever. Now, clearly, this is something that is going to require huge amounts of concentration for very long periods of time, knowing that if he makes a mistake, then he's going to die. A fellow climber, Tommy Caldwell, was once asked to try and put his performance in perspective. And he basically characterized it like this, saying, imagine repeating an Olympic gold medal performance for 4 hours, and if you make a single mistake, you'll die. That's the level of performance it takes to free solo El Capitan. Next up, let's talk about situational awareness. And this is where an athlete has an ability to understand what's going on around them almost intuitively. They have the ability to make decisions under extreme amounts of pressure and time demands based on the situation that presents itself. Elite athletes, often when we're watching them, they'll seem to be one step ahead. They'll be able to make just the right decisions at just the right time, and they'll be able to anticipate things coming up that other people just haven't seen. One of the characteristics of elite performance, then, is this ability to have attentional flexibility. What we mean by this is to be able to focus from small details to large-scale situational awareness and then back into the details again. Here's an athlete who is very good at this. We can see here Messi has not only got an amazing level of control of the ball, so high precision, high attention to detail, but at the same time he's got amazing awareness of where other players are and where they're moving towards him and away from him. Attentional awareness and attentional flexibility is easier in situations that are self-paced, such as archery, for example. They're much harder and much more challenging, as you might imagine, in open skills, for example, dribbling a football. Let's look at how this attentional flexibility works. It's the ability to shift your attentional focus during competition. Attentional focus can be viewed along two different dimensions here. We're going to be thinking about the width, i.e. the attention can either be broad or narrow, and the direction. It can be either external or internally focused. Let's have a little look at each one of these situations and see if we can come up with a sporting example of each. First up then, a broad external focus is used to rapidly assess the situation, taking into account multiple changing factors around us. This is Lionel Messi's ability to dribble through an environment whilst at the same time maintaining control of the ball. He's able to assess the movements of different players, movements of teammates, and indeed also time his own dribbling to coincide with playing the ball through his opponent's feet as they come in to make a tackle. This is a broad external attentional focus. Another example here we can see in this little animation, we can see the ice hockey player in white having the situational awareness to step out to the left when he sees the other player racing towards him, in thus avoiding the body check. If we think about a broad internal focus, then this is going to be used in order to analyze and plan. For example, it's an athlete analyzing strengths and weaknesses in order to plan a season. So we're thinking broad because it's a whole season. However, we're looking internally because we're looking at strengths and weaknesses arising from the internal elements of that athlete. For example, being able to sit there at the beginning of a season and identify your strengths, weaknesses, opportunities, and threats that are going to appear throughout the season in order to be able to anticipate and plan for them. Next up, let's consider a narrow external focus. So this is where we see the focus being devoted exclusively towards one or two detailed external cues. An example of this could be a table tennis player focusing on the details of a ball's trajectory during a competition. These things that they might focus on might be the trajectory, the velocity, and the spin of the ball. All things which are going to be really important when planning the return of that ball. Finally, let's consider a narrow internal focus. So this is going to be used normally to mentally rehearse an upcoming performance or control an emotional state. We're focusing on something really specific here, not long duration over the course of an entire season, but a specific situation at a specific point in time. It's internal because we're looking within ourselves in order to try and control that emotional state or rehearse that upcoming performance, for example. Here's a good example of a skier about to take part in a downhill race, and you can see them visualizing the turns that they're going to make and how that's going to feel once they're on the course. Next up, let's consider the distractors which might end up influencing our concentration. We're going to be asking ourselves, why do skilled performers end up losing their concentration? This is a particularly serious problem when the performers are put under high levels of stress and pressure. We're going to split these into internal and external distractors, and we're going to start off looking at those internal distractors. These are, for example, our thoughts and our feelings, and we can see some examples of these now. We can see that these thoughts are negative and they're focused around questioning our potential for producing a positive outcome. Next up, let's consider external distractors, and these are irrelevant bits of information or cues coming from the outside. So that could be a coach shouting a last-minute bit of instructions, or it could be the photographers in the crowd and the flash guns going off on the cameras, or it could be the crowd themselves cheering and shouting. Or finally, it could be the weather conditions, so for example, the rain or the temperature. All of these things could end up distracting and taking away from your original focus. Let's discuss now some of the things that we can do in order to try and increase our level of concentration and decrease the effect of distractors. So Professor Moran stated there are 5 key building blocks of effective concentration. He identified the decision to concentrate is really important. It's not going to happen by chance. We have to decide that we're going to switch on. We could use mental cues in order to help us focus our attention and switch on that concentration. So for example, walking into a changing room could be a good cue. Right, now's the time we need to start focusing and concentrate on the competition at hand. Next up, he suggested that we should only be focusing on one thought at a time. This means that there aren't other thoughts in our mind that are going to be ending up distracting what we're focused on. We're also going to be thinking about making sure that we're doing exactly what we're thinking. So when our mind is focused, we're making sure that our thoughts and our actions match. He suggested that we lose concentration when we focus on factors that are outside of our control. So, for example, the weather. He also suggested that when we're nervous or in a high-stress situation or fatigued, that we should be focusing outwards and we should be focusing on the here and now. In addition to these key building blocks, we can also look at concrete techniques and methods that could be used in order to try and increase concentration and decrease the effect of distractors. First up, let's consider deliberate decisions. And early on in this unit, we decided that the ability to concentrate is not something that's going to happen accidentally. It's something we need to actually invest some conscious decision-making effort into doing. So it can be triggered by identifying task-relevant information, and this increases the control for how and when we wish to direct our attention. An example of this could be that a golfer might use some specific words in order to try and increase the levels of concentration and highlight at what point we need to switch on our concentration and at what point we can switch off. Another method of improving concentration could be focusing on performance goals, and this means focusing on task-relevant goals and not performance outcome goals. This is going to increase our level of concentration because we're focused on the details of our performance and not just on the outcome, i.e. the end result. A good example of this might be a cyclist focusing on maintaining a smooth pedaling style, particularly as they fatigue throughout a bike race. Next up, let's consider the use of trigger words. So using these specific words can direct attention to particular key properties of the skill that's being executed. They can either involve instructional or motivational phrases and can be used positively or negatively. Here we can see an example of a really talented climber in the UK who's climbing an incredibly hard route. Now they've practiced this route on top rope and they're using the trigger words top rope, top rope, top rope to convince themselves that they're still safe, despite the fact that if they fell off at this point, it would result in probably severe injuries if not hitting the ground. Let's have a quick look at the video. So we can see on the left by his left foot, that is his last bit of gear or protection. As he makes this next move up onto the arete, we can see he's quite a long way above his gear, which would mean that there'd be a huge fall resulting if he came off at this point. So we can hear him now positively self-talking to himself. So there's some good examples of some motivational self-talk. And here we can hear him convincing himself that he is in a safe situation and that he's completed the climb on top rope, and so this shouldn't be any different when he's doing it on lead. Although, of course, if you know anything about climbing, it definitely is. Now we can see him successfully completing the climb. Next up, we can consider performance routines which can be used in order to increase our concentration. What we mean here is that we perform a series of repetitive behaviors, typically right before we execute a skill. The idea here is that it increases focus on relevant information, prevents overthinking, and increases feelings of control and comfort. Here's a good example of Jonny Wilkinson using a pre-performance routine before a kick in rugby. So he would always line up the kick in the same way. He'd take the same number of steps back and then step to the side the same number of steps, and then adopt the same position prior to kicking the ball. This was his way of mentally preparing and focusing in on the task at hand. And if you know anything about Jonny Wilkinson, normally he was successful. Finally, we can consider mental practice. So this is where we can go through a skill mentally in our mind using our imagination before we execute it. Different situations can be visualized to encompass a range of different skills. Now, there's quite a lot of evidence out there that mental practice can facilitate learning and performance increases. However, its use as a concentration tool remains uncertain and it needs more research. Let's look now at arousal and attentional narrowing. So the attentional capacity that we have as an athlete at any one time is going to be related to our level of arousal. What we mean by level of arousal is just how physiologically and psychologically stimulated we are from low arousal to high arousal. The curve you can see here on the graph is going to represent the relationship between performance and levels of arousal. What we can see then is that we have an optimal point of arousal around the middle, with the performance levels dropping off if the arousal level is lower or if arousal level is higher than our optimal level. Just remember, we need to consider not only psychological but also physiological impacts as well. So with the increased physiological activation, we get increased heart rate and breathing rate, increased levels of muscle tension, and this can lead directly to feelings of excitement or anxiety and stress. And if this is too high, that's going to lead to a decline in levels of performance. Have a little think now about what sports might benefit from higher or relatively lower levels of arousal. And consider, is our optimal level of arousal going to be exactly the same for all situations? When we consider attentional narrowing, this is similar to selective attention. The idea being that with low levels of arousal, our attentional field is too broad, and our attention is drawn to both appropriate and inappropriate cues at the same time, and we're unable to differentiate between the ones which are pertinent and those which aren't. As we increase levels of arousal, generally speaking, we're going to increase levels of focus and attention, and this is going to be focused on a more limited set of cues and stimuli. Hopefully, at this point, we're able to identify which are the relevant cues and focus purely on them. However, it's not always the case that the higher the level of arousal, the better the focus or attention, because it can be negative if we become fixated on single cues or a small number of cues that aren't actually relevant, or we start becoming fixated on internal thoughts and self-doubt and worry. So our performance can actually decline with higher levels of arousal. In addition to this, attentional narrowing can have negative effects on those people playing open sports, so for example football or rugby or basketball, who need to have an overview of what's happening all around them. Too high a focus on the execution of a specific skill is going to mean that attention is drawn away from that global situational awareness, and even though you can execute the skill perfectly, you might be doing so at the wrong time or in the wrong place. This is a good example of how attentional narrowing can lead to a decline in performance. So it's not necessarily that the higher the attentional narrowing, the greater the performance. We tend to see a relationship more similar to the one that we just looked at in terms of arousal and performance, where we have an optimal level of attentional narrowing depending on the situation. When we're talking about attentional narrowing, we can also talk about maladaptive attentional narrowing. This can be caused by stress and anxiety, and it causes the athlete's attention to become too narrowly focused, and this leads them to miss cues that they would otherwise be able to perceive. This differs from focused attention, which is the deliberate and adaptive narrowing of attention to focus on task-relevant information, because it actually means that we're too focused and we end up missing cues, so therefore it has a negative impact on our performance. Mental toughness training can help to prevent maladaptive attentional narrowing by improving an athlete's ability to recognize stress response, manage distractions, and also maintain that attentional focus flexibility, meaning that we can adapt our focus from the small details to the overall situational awareness that we need when we're playing sports. Let's consider now how attentional focus can impact our ability to acquire motor skills. When we talk about sports coaches and physical education teachers, we need to know and understand how skill learning can be facilitated and how performance can be optimized. Attentional focus often has similar influence on both the immediate performance during a practice phase and the learning of a particular motor skill. A coach can therefore determine the focus of an individual in order to get the desired outcome in the learning process. For example, we can look at how a coach might decide that an athlete should be focusing on an associative focus. That is where they're going to be acquiring a skill and they're going to be thinking about focusing on their bodily sensations. So what's going on? They're getting engaged with exactly what they're doing. Alternatively, during training, a coach might ask a student or athlete to become dissociatively focused, i.e. that means blocking out sensations. This is particularly useful when the level of physical effort is quite high. The coach might also promote a broad width, so for example, being able to focus on a multitude of different cues from a number of different sources within the particular environment, the ability to scan the environment for appropriate cues. Alternatively, focusing on a narrow width, looking at one or two cues that are specifically execution focused of that specific skill. The coach could also promote an internal focus where the athlete is going to be largely taking into consideration the sensations and the feelings of the technique being executed from within their body. Or they could promote an external focus where they're looking at the effect of the movement or the influence of their movement and their play on the environment around them. Overall then, skilled performance is associated with two different elements that we're trying to improve. We're trying to improve effectiveness, such as the accuracy, consistency and reliability of achieving that goal, and also the efficiency, so the amount of energy that we outlay in having to achieve the same result. Here we can see a quick comparison table which is focusing on the advantages and disadvantages of when an athlete might want to focus on an associative approach or a dissociative approach, a broad width or a narrow width, and an internal and an external focus. Now let's have a look at how we can use focus of attention strategies in order to improve our performance via the improvement of perseverance. So psychobiology sees endurance fatigue as exhaustion that's not related to an inability to continue physiologically. Rather, it's a psychological block where the individual decides to give up before their physiological limit. If we can use some attentional strategies to help us push beyond this limitation and attain our true physiological limits, this could help improve our performance in a number of different sports, for example, cycling and endurance running. This 2013 research paper looked at an individual cycling athlete and his time to exhaustion when applying a dissociative focus versus an associative focus. They set the exercise intensity at his anaerobic threshold plus 10%, and they allowed him to maintain his optimal pedaling rate. What they did is they first set a dissociative focus where they asked the athlete to focus on a metronome that reproduced his optimal pedaling rate. They then did the same experiment again where they asked him to use an associative focus where he was asked to focus on his internal rhythm while maintaining his optimal pedaling rate but without the metronome. The results were significant. The dissociative focus resulted in a time to exhaustion of 28 minutes, whilst the associative focus saw the time to exhaustion drop to 26 minutes. The implication here is that when we use a dissociative focus, that increases our levels of perseverance and convinces us to give up later rather than when we focus on what's going on internally. However, conclusive agreement on the merits of either an associative or dissociative focus have yet to be reached. There's clearly certain advantages in certain scenarios of both situations. For example, you wouldn't want to be cycling an entire bike race with a dissociative focus where you're trying to avoid focusing on the relevant cues, as this is clearly going to be dangerous, as at certain points during the race you're going to have to focus very sharply on what's going on around you. To finish this unit then, let's consider how attentional control and non-linear pedagogy really go hand in hand. If we remember, non-linear pedagogy is based on the ecological dynamics approach, where coaches are encouraged to try and put as much practice into an environment that is consistent with the competitive environment the athlete is going to experience. So strategies that consider attentional focus can help athletes or coaches design these learning environments and improve the learning and performance that result from it. For example, shifting focus of instructions from internal thoughts and processes to external outcomes or effects of the movement causes learners to use their self-organization and adapt movements without relying upon conscious control or instructions from the coaches. This encourages learners to adapt their strategies and behaviors based on the individual needs of the specific situation that they are experiencing. So by prompting athletes to switch the focus of attentional control from broad to narrow, internal to external, we can promote that adaptation that is so highly sought after by a non-linear pedagogical design. That concludes this unit and indeed C2. If you have any questions, please don't hesitate to get in touch. Thank you very much.